Well, just like arithmetic, we had sequences, and now geometric had sequences, and arithmetic had series, and now geometric has series. Remember what series means? Series means to sum, but geometric means, yeah, we got a common ratio that we multiply things with. So, which is a series? Which is a sequence? Okay, sequences, series. You know what? They're in alphabetical order. So if you ever forget, this is a sequence, right? Okay, with the commas. Series is the next one. That's why we always refer to them as sequences and series as well, because that helps us to remember them. So all you did is you took this crazy sequence and you just added things up. Now, so look at the definition. Geometric series is where the terms are expressed as a sum. So all you got to do now is figure out how you're going to add them together. So looking at the technical definition, okay, replace the commas with a positive. Positive meaning adding. Terms are determined by, yep, common ratio. Now, there's got to be a formula that goes with this. And in fact, it is. It's a pretty complicated formula too. Sn equals to this. Now, the important thing to remember here is this. R, which is your common ratio, cannot be equal to 1, because if it's equal to 1, look, 1 minus 1 gives you 0, which means, yeah, that's a non-permissible value. That's not allowed. But looking at this particular formula a little bit closer, you're going to see some interesting things. And we're going to put it to use right away. First one, T1, still the same. That's the first term. Ratio, still the same. Ratio appears here and here. N now, remember, is the number of terms, but look at the difference between this. N, before, when we're finding this, Tn equals to T1 r to the n minus 1. Remember how this was an exponent. Well, guess what? The r is an exponent still, but the minus 1 is just a normal number. Okay? So you still use r to the power of n, but then you just subtract 1, which kind of sounds silly, but that's how it works. Okay? All right, so there's also an alternate formula that goes with this. Just a little bit different, and we're going to examine that alternate formula when we get into a couple of interesting questions later on additional podcasts. So, okay, let's go. Let's put this to work. Here we go, example number 1. All right, says for the following geometric sequence, write the sequence as a series. No problem. Minus 5 plus 10 plus minus 20 plus ... and you keep on going forever and ever. This, of course, is an infinite. Now, determine the sum now of the first 15 terms. Well, that would make this n, right? Next thing is, that is T1. And like I always said to you in every podcast we've done, especially when we did arithmetic, try to find D first. In this case, we don't have D. Because it's geometric, we should always try to find R. So let's go right out and find the R right now. Here we go. Ratio 10 divided by the term in front of it. Minus 5 works out to be minus 2. There's your R. So we got to find the 15 terms with a ratio of this and a T1 of that. Let's use the formula. So what do we got? We have two possible formulas we can use here. We can use T1, okay, is R. Yes, we've got R. Yes, we have N. We're good to go. That's the formula I'm going to use right off the bat. I won't even look at the other one. So this now means the sum of 15 terms equals to, well, T1 is minus 5, bracket R, we figured out to be, oh, there it is, minus 2 to the power of N. Remember, there's N. Those N's have to be the same. So it's minus 2 to the power of 15. Now, wait a second. You're probably saying, well, why are you putting a bracket like this around the minus 2? Don't forget in your calculator, if you don't put a bracket around this, right, and raise it to whatever power it is, it's always going to end up being a negative. If you want to include the negative, which is exactly what we want to do, make sure you put a bracket around that. So we're running a whole bunch of brackets as we go again. So let's review. Just here we go. Sum of 15 terms. There's T1. There's your ratio to the power of 15. Subtract by 1, okay, divided by the ratio subtract 1. The ratio, minus 2, subtract 1. Oh, what a mess. Okay, well, so what? We can figure this out, no problem. Easiest way to do it, bring up your calculator. Okay, so let's bring up our calculator. There it is. And we know our first thing that we're going to do is we're going to do BEDMAS. Well, let's do minus 2 to the 15 first. So bracket minus 2 to the power of 15. It's going to be a big number. Check it out. Woo, that's a huge number. And then we're going to subtract 1 from it because that's what this tells us to do. Whatever this was, subtract 1. Okay, so bring up the calculator. We're going to subtract 1, minus 1. Beautiful. Answer. Ta-da. Then we're going to multiply it by our T1 term. All right, times this by minus 5 gives you an answer of, holy smokes. And now divide it by whatever we have down here, which is, of course, equaling to minus 3. So take this and divide it by negative 3, and you get an answer of negative 54,615. Negative 54,000, what? 615. Got it. And that's your answer, and that's how you use a sum formula.